I want to create a video for the quiz over 6-1 to 6-4 that you will take virtually during class on Monday. And I want to make sure this is something that you can watch ahead of time. This is something that you can take notes on. You can write these examples down and then have that to utilize. I copied and pasted some questions from Delta Math, and then I had some other ones that I had already had that I thought were really good matchups for what you have to do. So we're going to start with exponent rules because that's going to be the first thing on your quiz is working with your exponent rules. So for the first one, you're going to multiply your numbers together first. So you're going to take 3 times negative 14. And again, if you need a calculator, you can do that. So that's negative 42. And then with my variables, since the bases are being multiplied, we're going to add our exponents. So we get x to the 5th power and y to the 9th power. So your coefficients are treated just as any operation, and definitely use a calculator if you need to. Your variables, we use exponent rules. Next one, we have to take negative 2 to the 3rd power. Again, you can use a calculator for that, or in your head, multiply negative 2 times negative 2 times negative 2. You get negative 8. And then for my exponents, I'm going to multiply my exponents since the power is being taken to another power. So we're going to have x to the 12th and y to the 15th. When it's written as a fraction, the first thing you want to do is you want to simplify the fraction. You can do it in your head. You can even grab a calculator and type it in and just make sure you convert it back to a fraction. 27/18, each of them can be divided by 9, so you get 3 over 2. Now with the variables, you want to look and see where do you have more of the variable. So where is the exponent higher? That's where the leftovers will be. And you want to see how many more by subtracting. So with your x's, you have 6 x's on the bottom and 1 on the top. That means you have 5 more on the bottom. So you're going to have x to the 5th on the bottom. And with your y's, you have 7 on top, 1 on the bottom. So that means you have 6 more on the top. So that is your answer. The next one, you are going to want to take negative 4 to the negative 3rd power. So one thing with this, when it's a negative exponent, probably the best way to treat it is immediately move it all to the bottom, anything that has that power. So if it's in parentheses, the whole parentheses moves down. If it's just one value with that power, then just that value moves down. So we're going to move the negative 4x all down to the bottom and make it positive, because that's what a negative exponent does. It flips it all to the opposite part of the fraction. Then I'm going to multiply it out. So I'm going to take negative 4 to the 3rd power, which is negative 64. And then power to a power with the variables, I'm going to multiply x to the 1st to the 3rd. So 1 times 3 is 3. Keep in mind, so if the parentheses weren't there, if it just said negative 4x to the negative 3, that would only have the x going to the bottom. So that would keep the negative 4 on top and just move the x to the bottom. You really want to look at what has the negative exponent so you move the right thing to the denominator. Next one, we're going to multiply the bottom out first before I touch the top. So I'm going to have 20j to the 6th over, I'm going to multiply the exponents in the bottom. So 5 times 2 is 10. So I'm going to have j to the 10th. Now I'm going to reduce my numbers. So 20 divided by 4 is 5. And then I'm going to subtract my exponents. I have more j's in the denominator, 4 more to be exact. So that means I'm going to end up with a j to the 4th in the bottom. Next thing that we did in 6-1 is we looked at ones that perfectly worked out with radicals. So this was before we got to the ones where we had to do a lot of factor trees. Square root of 121 is 11. And then for the rest of it, I'm going to do the power divided by the root. So the power is x squared. The root is 2. So 2 divided by 2, I just get x to the 1st. And then 6 divided by 2, I get y to the 3rd. So these worked out perfectly in the first section. Cube root of 125 is 5. And then I'm going to do power over root. So 9 divided by 3 is 3. 15 divided by 3 is 5. That was section 6.1, everything that we did at the very beginning of the chapter. Moving on to 6.2. 6.2 were the ones that took probably the most amount of time of anything that we did in this chapter was probably 6.2 because we made a lot of factor trees. So you need to break down the number that's under the radical into something that is perfect. So this is when it really helps to have all your reference lists by you. You had a perfect square reference list, a perfect cube, a perfect fourth, a perfect fifth. You can also use your calculator to help you create those again. So the perfect cube of 40 is 8. And I like to put a box around the one that's perfect. With the variables, you want the power to divide evenly by the root. And if it doesn't, you want to drop down to the first exponent that does. So 4 does not divide evenly, but 3 does. So we're going to drop it down to x to the 3rd. Y squared is actually too small to ever be perfect because the power is below the root. So that's going to stay put. And z to the 6th is already perfect. So I'm going to keep that where it is. I like to put boxes around all the perfect parts. So the square root of 8 is 2. The square root of x to the third is x, or sorry, not square root, cube root of 8 is 2. The cube root of x to the third is x. And the cube root of z to the sixth is z squared. And then everything that was not perfect, which was the 5, the x, and the y squared, will all be left under the cube root. If you're asked to multiply ahead of time, you're going to multiply everything that's under each radical. So 5 times 15 is 75. X to the third times x squared is x to the fifth. Y to the eighth, so I'm adding exponents. Now I want to break this down. 75 is not a perfect square, but 25 is. So I'm going to put a box around that. X to the fifth is not a perfect square, but x to the fourth is, with a leftover x. Put a box around that. And y to the eighth is already perfect because the power will divide by the root evenly. So I'm going to take the square root of all the stuff that I put in a box. So the square root of 25 is 5. The square root of x to the fourth is x squared. The square root of y to the eighth is y to the fourth. And then underneath my radical, I still have a 3 and an x. And that's it. That's my leftovers. Next one is the same idea, but it's a cube root. So first I'm going to multiply together first. So 16 times 4 is 64. And then I'm going to add my exponents of x. I'm going to add my exponents of y. And the whole thing is now being cube rooted. 64 is a perfect cube, so I do not need to break it down if it's perfect. I'm just going to put a box around it to remind me that. X to the seventh is going to break down into x to the sixth and x because 6 divides evenly by 3. Y to the eighth is going to break down into y to the sixth and y squared. All the stuff that is perfect, I'm going to take the cube root. Cube root of 64 is 4. Cube root of x to the sixth is x squared. Cube root of y to the sixth is y squared. And I still have left, what do I have left? An x and a y squared. Everything that's left, the powers should be less than the root. So if it's bigger than or equal to, that means you didn't take out enough. And then finally in 6.2, we did division. So with division, you want to divide everything first. So 32 divided by 2 is 16. X to the fourth divided by x is x to the fifth divided by x is x to the fourth. And then y to the seventh divided by y to the fourth is y cubed. 16 is not a perfect cube, but 8 is. X to the fourth is not a perfect cube, but x cubed is, with a extra x left over. And y to the third is already perfect. So I'm going to take the cube root of all my perfect pieces. So cube root of 8 is 2. Cube root of x cubed is x. Cube root of y cubed is x. And the only thing I'm left with is a 2x under the cube root. Same thing with the next one. I'm going to divide first. This is a square root, though. 21 divided by 3 is 7. X to the 11th divided by x to the fourth is x to the 7th. Y to the 6th divided by y to the fourth is y squared. So 7 is not a perfect square. It's actually a prime number, so I can't do anything with that. That 7 is going to be stuck, so I'm just going to kind of underline it. Like there's no perfect part. X to the 7th, I'm going to have to break it down into x to the 6th and x. And y to the second is already perfect because the power will divide by the root. So when I take the square root of x to the sixth, I get x to the third. The square root of y squared is y, and I am still left with a 7x underneath. So that was section 6.2. We did a lot of factor trees, a lot of breaking down. We have examples from class lessons, from past videos that will help you. Moving on to 6.3. So 6.3 was focusing on adding, subtracting, and multiplying radicals. So when you're adding, in order to add, you have to have the same thing under the radical. So to do that, we're going to have to break it down again. So you're going to have numeric ones and variable ones. We'll do the numeric first. So the square root of 200, 200 breaks down into 100 times 2. And 50 breaks down into 25 times 2. When you take the square root of the perfect one, so you get a 10, you're going to leave the square root of 2 there. And then the same thing with the next one. The square root of 25 is 5, and you're going to leave the square root of 2 there. Now we can add them up. We call them like radicals that we can add. So we're going to add the coefficients. We have 10 root 2 plus 5 more root 2 is 15 root 2. If there is a number in front of the radical, that number will have to be multiplied by whatever you bring out. So you will see ones that have some extra pieces that you have to make sure you work with. Actually, the next one's very similar to that. So 125 is not a perfect square, but 25 is. It's 25 times 5. And 45 is not a perfect square, but 9 is. It's 9 times 5. As far as the variable, I can't do anything with the x here, but I can break down the x to the fifth into x to the fourth and x. So I want to keep doing what I did in the previous section. When I take the square root of 25, which is 5, I'm going to bring that 5 out front and I'm going to multiply it by what's already here. So I'm going to have a negative 6x squared, but I'm also going to multiply it by a 5, which is going to give me negative 30x squared. And I still have a 5x underneath. With the next one, I'm going to take the square root of 9, which is 3, but I'm going to multiply it by the 2 that's already there. So 3 times 2 is 6. And then I'm going to have to take the square root of x to the 4th, which is x squared. And I am left with a 5x underneath. Anytime you are asked to add your leftover parts, that radicand, have to be the same so I can add them up. So now I have negative 30x squared plus 6x squared. Well, negative 30 plus 6 is negative 24x squared. And my radical part does not change. The square root of 5x is still part of your answer. Then we did multiplying ones. We did multiplying ones that were and weren't conjugates. So 5 times 7 is 35. These are going to be FOILed. My outer is going to be negative 5 square root of 3. My inner is going to be 7 square root of 3. And my last, negative square root of 3 times a positive square root of 3 is just negative 3. And when you're done with the FOIL, so once you do all 4 parts of FOIL, you are going to want to combine your like terms. So 35 minus 3 is 32. And then I have negative 5 root 3 plus 7 root 3 is 2 root 3. So those are the longest ones. We also dealt with ones that were conjugates. If they are conjugates, they will be identical except for a plus here and a minus here. When you see that, instead of all 4 parts of FOIL, you're not going to have to do the outer and inner because they will cancel. So 2 times 2 is 4 minus 5 times 5 is 25. And then root 6 times root 6 is 6. So you're going to have 4 minus 25 times 6 is 150. You can use a calculator if you need it. You get negative 146. But anytime you're asked to multiply binomial, think about your pattern of foiling. First, outside, inside, last, and then see what terms you can combine. And finally, we are on to section 6.4. Oh, I went too far. Sorry about that. 6.4 was looking at rewriting, and we did this a little in 6.1 as well, fractional exponents and radicals, and then also using exponent rules with fractional exponents and radicals. So the first one, it's a fifth root and a second power, so power over root is 2 over 5. Power is always the numerator of the fraction, root's the denominator. This one's doing the reverse. It wants you to write it as a radical, so it's going to be x cubed being square rooted. You don't have to put the 2 on the tip. It is understood. I want to get rid of this one piece because it is not, we're going to do this on another screen. So I'm just going to move that out of the way. The bottom ones are reviewing your exponent rules. So the first thing you want to do is you want to rewrite it with fractional exponents. So this is going to be the 2/5 power. This is going to be the 3 over 2 power, power over root. And then you're going to add your exponents. And you can totally do this on a calculator so you don't have to worry about messing up your arithmetic. So you can take 2/5 plus 3/2. And just make sure that you get your answer as a fraction. So 2/5 plus 3/2 is 19/10. So your exponent is 19/10. The next one, the x needs to be written as the 1/2 power instead of a square root. Now I'm going to apply this power to everything. Now with the number, remember, you can just do it in the number part in your calculator. So you're going to take 27 to the 1/3 power, that is 3. Again, totally on your calculator, use your exponent button. And then you're going to multiply your exponents. So you're going to take 1/2 times 1/3, which again, you can use a calculator, you get 1/6. And then you're going to do negative 2 times 1/3, which is negative 2/3. Use a calculator if you need to. Finally, the directions will say no negative exponents, positive exponents only. So anything that has a negative exponent needs to move. So I'm going to keep the 3 and the x to the 1/6 where it is, but I'm going to move the y to the 2/3 to the bottom. Next one on this, we need to rewrite the denominator. So we have y to the 2/3 over y to the 1/4 power. I'm going to multiply my powers together. So I'm going to do 2/3 times 1/2, which again, you can use your calculator. You get 1/3. And then I'm going to multiply 1/4 times 1/2. I get 1/8. And finally, I need to subtract those exponents. So I'm going to grab my calculator. I'm going to type in 1/3 minus 1/8. I'm going to convert it to a fraction. I get 5/24ths. So my final answer, I'm just going to put it up here because I feel like I'm running out of room, is y to the 5/24ths. So a lot of steps are happening there. I want to finish with just a couple that I copied directly from Delta Math, just so you get used to what they're asking you to do. So I'm actually going to do the one on the right first, just because it's simpler. This is going to ask you to use exponent rules, and all you have to type in on Delta Math is the new exponent. So for this one, which is really fast, you're going to subtract exponents. So you're going to do 3/2 minus 2/5 on your calculator. So 3/2 minus 2/5 on your calculator, convert it to a fraction, and that's going to be your new exponent, which is 11/10. So all you're typing into Delta Math is the value of the exponent. So you are just going to type in 11/10. Same thing on this one, the first one. This one's just a little more complicated. I'm going to rewrite the radical first. So I have x cubed to the 1/4, and I'm going to rewrite that as x to the 4/5 power over root. I'm going to multiply these powers together. So 3 times 1/5 is 3, 3 times 1/4 is 3/4. So I have x to the 3/4 and x to the 4/5. Again, I'm going to grab my calculator and I'm going to add the exponents. And that's going to be my answer because the answer wants to know what your a value is. So I'm going to type in 3/4 plus 4/5, and I'm going to convert it to a fraction, and I get 31/20. So you'll notice that in some of the problems on Delta Math, they want you to tell the new exponent after you've applied all the rules. All you're going to do is type in that fraction, and you are welcome to use your calculator to help you with all of the arithmetic. And that is everything you need to know to be successful on this quiz.